Okay, I'll try my best to make up for some of the time. Get those cords a little bit out of the way. So let's keep that as interactive. So if you disagree, protest, stand up, scream, just let's get it as a dialogue. Of course, I don't know what makes clinical trials successful. I can just show some of the caveats. But many of the trials, also including things we have seen, we knew well ahead of time that they're going to be negative. And I will highlight some of my own work for the failures because it's easier to criticize your own than being outsmarting all the others. So, when you go in, define for yourself why you're going in. And I listed here and I mentioned some of it. And, it is to really advance science to ultimately help patients. But we are also, all like to be standing on the podium and being invited to beautiful Liverpool and having a tour at night. So kind of being on stage is also what we want. And I remember the first time when I actually didn't get my stage presentation for my temozolomide work, I was very disappointed. It was the best thing that could happen to me. But really get your priorities right. And you need to have the fire when you do it. And I think that's what I see, especially now with all the paperwork, etc. People don't even read the protocol anymore their PIs on, not even talking about having written it. We had to write them. We had to write the consent form. Now, of course, nobody can read and write 25 pages and then the summary of the 25 pages of consent. So kind of get that. Get your question clear. And your question is not, I want to publish a paper quickly, but what question do you need to answer? If you get that straight, that already helps. And then don't forget what I mentioned yesterday. The focus is the patient, but the trial is an experiment that has a design. So you have two roles. When I sit in front of a patient, I'm not a scientist. When I design a trial, I have to get the science right. So that's what I already said. Really look at the data, what is out there. Go back. And I gave a little bit yesterday, and actually lovely things when I'm asked to give a trial of the past, and I go into old literature, and you see things you have done and others have done. Look at it. Our attention span is very short. The next generation comes. People don't know what generations have done. And we tend to come up, as human beings, come up with the same ideas over and over. So we reinvent it. Radiation oncology, please apologize for the ones in here. They're going to do the same things again because they have a new toy, a new machine. So I think I'm going to rewrite every manuscript again because I got a new Apple computer. So kind of look what is there and what's the foundation we can build on. How to do that as a strategy, pressure test it within your team. Okay, get killed there rather than by the reviewers. A good way to start is also writing your review. On one side, I feel like we have way too many reviews and way too many publications out there. But if you want to get things right, write a review. That forces you to have everything done. I checked whether this is true and things we have done, and indeed I wrote a review on temozolomide in Lancet Oncology that was published in 2001, and it was a review, but it was an editorial we wrote with Adam Sonnab for all the blood-brain barrier and so ultrasound work. So kind of that pushes you to get your thoughts right. Not the only one saying that, and just reviews. While preparing for this talk, I was stumbled over that review where when you pull it up, you're going to have all the questions nicely laid out, and that's the good foundation to then see how you're going to address those questions. The scope of your investigation, what's the objective? People always get the objective and the endpoints confused, and it's not always clear. The endpoint is what you measure, and the objective is what you want to achieve. These are two, in principle, different things. and you can only measure certain things. Now, for the next generation, that should not be an issue because you guys score everything. So, give you an anecdote. We had friends as a visitor coming for dinner, and they brought their 7-year-old son, and he liked the food, so he went to my wife and said, "Oh, I give you 5 stars for this dinner," okay? Because everything is scored. Every Uber, every taxi you take. So, shouldn't be that difficult, but sometimes it seems it is. What drives you? And I went back here again. I'll try to have it this personal experience and history. So this is really, and we still remember her, the patient that got started on temozolomide, was 25 years old at the time, coming with the glioblastoma. Probably now we would know this as an IDH mutated tumors. Of course, at that time, we didn't know that. We treated her, and that was the index patient to get temozolomide and radiation going, because I felt we have to do something else. So this patient did well almost for 4 years, but after 3 years she had progressed, and she did progress locally, but she had dissemination. So there was tumor in the CSF, and that's something I've shown yesterday with that gravitation to the brainstem that we see. So based on this, I said, okay, the next step, if I had got the local control right, is can I avoid migration, dissemination? And going through the literature and what is available, what is integrin inhibitors, namely selengitide, as a rational way to do so. So we did a trial. We did a phase 1 and phase 2 trial, and we got the results as they were. What were the mistakes? The phase 2 part we wanted to do randomized. We actually realized it, but we couldn't get industry support. No, you have to do just the uncontrolled trial. And then you, at the end of this trial, with results look a little better than before, but non-conclusive. So we didn't have the data to really decide on go or no-go. But they didn't have the data either to kill the drug, in which by the time we went into clinical trials, already at least 100 million has gone into drug development. So that pushed us to go into a phase 3 trial. And because the signal of the 53 patients we were allowed, again, the statistics came after the budget, another mistake, then gave us, oh, maybe it's only the methylated ones. And what we did was a randomized trial, large phase 3, because we didn't have the information to also kill. And it's another of those trials where you can save money on the statistician. We actually got a hazard ratio of 1.0, what actually shows you randomization is a good thing. It works. So you can run the experiment. So at least here, $50 million later, actually it was way more than $50 million, actually we had a clear answer. So at least we got an answer. So the experiment worked. Maybe we could have done it a little easier. We didn't have to expose 600 patients to it, but at least we got an answer. Now, the funny thing is, so here I said, to get the budget for the phase 3, that was easy. I couldn't get $500,000 more euros at the time to actually get the phase 2 a little larger, even though we wanted. And that has to do how the things are, the reality of life. When you work with pharma, and nothing wrong about it, you have to work with them. They have to have a different perspective. They also always need for Wall Street the perspective and the phase 3 trial. So it's all a question of timing and a little bit of luck and who you. Please think outside the box. Be bold. You know, we've never done a true phase 1 dose escalation trial of temozolomide and radiation. That Ed Newlands did on the drug alone, and we combined it with radiation. There was not that much to lose. You have to go. There is ways to make that short. And that's not because we're playing with patients. Well, the opposite. But as a patient, you don't want to be treated with a too low dose. You don't want to be treated with too high of a dose either, but you don't want to be the 20 patients that go in until they even get to an effective dose. When you look at the data, be self-critical. Okay. You know, I had in the first paper on temozolomide promising in the title. I would not let that pass through. Okay, just be factual rather than over-reading it, and let the data speak for itself, and really produce data rather than hype. And I don't go into the many hypes you have seen in our field over the last decade or so. This I don't need to read, but this is, you know, it's so much Me Too. We repeat so many times the same thing. How many more Avastin trials could we produce? And how many more checkpoint inhibitor single agent trials can we produce? And you just heard on the talk before, you need actually for a checkpoint inhibitor that it has an interaction with the tumor. We know that monoclonal antibodies don't go in, but we have Bristol-Myers Squibb plus all the noblesse of the so-called KOLs on the paper who run 3 randomized trials up front doing checkpoint inhibitors for glioblastoma. So we are to blame ourselves, okay? We really need to advance fast. Now, you heard beautifully on the first talk by Dr. Lopez, you know, on the preclinical models. But after she talked and how many preclinical models, she said, but actually they don't predict for anything what we do. So let's move to, you know, the models are to show a mechanism. But then we treat wrongly every single patient every day, patients every day, where we don't learn anything. So we need to do something better. And I think there's an opportunity. And we just don't spend a decade to the perfect preclinical model. Take the models what they are, models to understand what you do. But then we need to move into humans. If one thing in the field of neuro-oncology is actually better than the other fields, we are here multidisciplinary. We have here neurosurgeons sitting at the table who do research. So we can integrate that. We can do phase 0 trials. Don't do phase 0 trials, do phase 0 alone, but you can integrate them into larger trials. Collect tissue. I don't know why it is so difficult to collect tissue. I don't know how many pathologists are sitting in here, and they have a basement full of old tissue blocks that will not get shared. Please share that. I think we need to decide how low the bar is. What does it mean if your mouse is living 60 days instead of 30 days? Should the mouse not at least be cured? I thought industry or somebody has those answers when I started in this field. They don't. So we have to realize that. But sometimes we have a little bit too much wishful thinking. Again, me included. We need the wishful thinking to keep us going. When do you treat? And I use everything here, the model of the glioma. But there, you know, you can transfer it. There's many other areas we should explore. So in glioblastoma, we can either treat upfront or in the recurrent setting. And I think each setting has its pros and cons. In the recurrent setting, major unmet need. We say, yeah, we can do it, and we can easily recruit. The patient is ready to try anything because they know nothing worked. We have really nothing good as standard treatment. But the disease is way too advanced. Patients are on steroids. So we give steroids and we give a checkpoint inhibitor and immunotherapy. You drive with one foot on the gas and one on the brakes, and the patients are fragile. There's not even enough time to have enough exposure. So for some, yes, you can, and you treat the patient because there's an objective there to really improve their quality of life. But the chances that you really see something is not very high. And I could have made this slide when I was actually making the argument using temozolomide up front, and that was kind of what I was saying at the time. If you look, no treatment, including temozolomide, works in recurrent disease. You always get the same kind of survival. So just be aware of it. And that's how curves can look like. And I could go on. I could go half an hour just showing you these kind of survival curves. Or you go in the newly diagnosed setting, but you have the challenge. You have to combine it with the standard of care, combine it with radiation, combine it with tumor treating fields now. And it's not a guarantee that it works. Bevacizumab didn't work, okay? But at least it was done in the right setting. Now, to be honest, it was done in the right setting after the regulators refused to approve it in the recurrent setting. Otherwise, we would never have gotten those trials. So there is a little bit of a mechanism how things happen. We talked about this methylation status. You need to take that into account, and if you don't control for methylation status, you're going to fail, because this is the strongest predictive marker. So it's so strong that it will blunt anything else. So Bristol Myers apparently listened to one of my talks in 2005 or whatever when I gave them, and indeed did trials separately, and I give credit, unmethylated and methylated ones, and no improvement in outcome. Both papers have been published in April and May of this year. Now, there is an issue with doing that, and I alluded to it yesterday, is the cutoff. You get a report, methylated, unmethylated, but this is a probability score. There is different technologies to do, but just measuring more methylation doesn't make it. There is just at the part of this exponential curve a gray zone of uncertainty. So if you want to enrich for unmethylated patients, that means you want to withhold temozolomide, which makes perfect sense. If it doesn't work, why give drugs that only going to add toxicity? You need a different cutoff that can't be in the medium. You need to be certain that you withhold temozolomide in unmethylated. While if you do the same thing in the methylated ones, you want to have this red curve move all the way to the right. And in the middle, that's the ones you need to give them, quote, the standard of care, because you just can't be certain of your prognostic effect. You can also say that with the performance status and your estimates, and I think if you do it could do it in a blinded way, I'm not sure you're going to give the same recommendation and performance status on a Friday night, tired and before going on holidays, or on a Monday morning when you come fresh back, full of energy. Opportunities you can do randomize upfront during radiation, but there's also after chemo radiation in the maintenance phase that you could introduce a new agent. Jump that. So overall, I don't have solutions. I think just really look at it critically. I mentioned it. Look at individual cases that are outside outliers. Now, some of the outliers also be critical. I heard on one of the talks, oh, we had 2 exceptional responses. Whenever I have exceptional patients, at some point they go back. Maybe it was pseudo-progression, and that sometimes I make fun of them, have one of those long-terms, or they have a mutation that is different that couldn't detect at the time. So usually it's the biology and not us. Look at it, team up with others, and really do things yourself for the young ones. Really try to get involved, get your hands dirty, despite all the bureaucracy that is shocking. With that, I thank you for your attention. I don't know whether I made it any time. Thank you.
Because we're generous, we'll take one question. Does anybody have any burning questions? If not, we will move straight on. But thank you for a very insightful. Thank you.